Hello everyone, this is Shweta and today I'm going to talk about my project which I'm going to do in NLP. So let me share my screen first. So I hope my screen is visible. So in natural language processing, and I'm going to do a project in text summarization. And before going to talk about the text summarization, let's talk about the language modeling. So have you ever wondered what is language modeling? So basically, we generally know what is a language, and we have different languages like Tamil, Telugu, Kannada, etc. Even we also have computer languages like C, C++, Java. Still, there are many more languages to know. But what is language modeling? So basically, language modeling is a core concept in natural language processing that involves predicting the probability of the sequence of the words in a given language. It aims to capture the patterns and relationships between words to understand the structure and meaning of text. So the language models are very essential for various NLP tasks, including text generalization and mission translation and speech recognition and etc. etc. So just wait a moment. So let's take an example to understand more clearly. So suppose if you are giving an input as the sun rises in the dash, so we need to fill the blank. So whether when the question is the sun rises in the dash, so we need to predict a word. So we can easily say it's a morning, right? So in this example, the language model trained on a diverse data set of a text is presented with the input text. The sun rises in the, and the predict the most likely the next word, which is morning. So the model has learned from its training data that the word morning often follows the phase. The sun rises in the, and it uses the knowledge to generate its prediction. The process at the heart of the language modeling, where the model training allows it to understand and predict the structure and pattern of the language. So, and here are some of the breakdown of the key aspects of the language modeling, like next word prediction, contextual understanding, applications, tokenizations, predictive learning, parameter optimization, and word embeddings, fine tuning, text generation, and challenges. So let's talk about each and every key clearly. So next word prediction, and it's a core, a language model calculates the livelihood of the next word or a token in a sequence based on the preceding words. It uses the context of the previous words to make predictions. And the next one is contextual understanding. Language model learns contextual and relationships between the words, enabling them to generate contextual and contextually appropriate text. For example, a good language model understands the sun rises in the dash is a lively to be followed them by morning rather than the refrigerator. And next is application key. So applications like, and we do many applications in NLP related to NLP. So in language model, Power Auto completes suggestions in message apps, improve search engines results, assist chatbots in generating human-like response, and contribute the sophisticated text-generated tasks. And the next one is tokenization. Tokenization is something text is divided into tokens, which can be word, subwords, or characters depending on the chosen grammar. And tokenization prepares the text for analysis and modeling. Suppose if you take a word, just take a word here, and here is a breakdown of a key. And if we just make this sentence as a key, tokens, here is a token, A is a token, breakdown is a token, off is a token, and da is a token, and key is also one of the token. So tokens can either be a word or a character or some other. The next one is predictive learning. Predictive learning, during the training, the model is presented with the sequences of tokens and learns to predict the next token based on the predicting ones. This prediction is based on the learned context, allowing the model to understand grammar, semantics, and common phrases. And the next one is parameter optimization. The model parameter and optimization during training to minimize the difference between its prediction and the actual text token in the training data. And this optimization process involves adjusting the parameters through the techniques like gradient descent. And the next one is the word embedding. This word embedding is very important in NLP. And this word in embedding, so in this, the language model often use word embeddings, which are defense vectors, representations of words. The embedding encodes semantic relationships between words and help the model understand words meanings based on their context. And the next one is fine tuning. After initial training, the language models can be fine tuned on a specific task. Fine tuning involves training and the model on a smaller dataset related to a specific task, such as semantic analysis or a text competition. This process adopts the model's general language understanding to a particular task. The next one is text generation. Once trained language, the model can generate a text by predicting the next word or token based on the given context. This ability enables applications like the chatbots, text competitions, and even creative writing. And the last one is challenges. Language modeling faces the challenges such as handling a rare or out of vocabulary words, avoiding biases present in training data, and sticking a balance between the memorization and generalization. And these are the keywords, and there are many more keywords, key breakdown keys that we use in the language modeling. So, and the next thing we are going to talk about is a language modeling. And there are two types of language modeling, which we have, which is N-gram models and neural language models. So let's see one by one each. This model predicts the next word based on the fixed number of prediction words, which is n-1. For example, if we take in a biogram model, the probability of the word depends only on the previous word. However, n-gram models struggle with capturing long-range dependencies. And the next one is neural language models. And these neural language models are more advanced models like those based on neural networks, leverages deep learning techniques to understand complex and linguistic patterns. These models, such as recurrent neural networks and transformer-based models like GPT-3 and BERT, can capture longer context and more. The next thing we are going to talk is challenges and advantages in this. And let's see what is this one by one. The first thing is a data sparsity. In gram models, the probability of unseen words sequences can be underestimated due to data sparsity. Neural models mitigate this by learning from vast amount of data. The second is long-term dependencies, and these long-term dependencies are traditional models like n-gram struggles to capture relationships between words that are distinct from each other. Neural models especially transforms excel at capturing the long-term dependencies. And the third one is pre-trained model. So in this pre-trained model, recent advancement like have led to the development of pre-trained language models like GPT-3 and BERT. These models was trained on a massive data set and can be fine-tuned for a specific task, saving significant time and resources. And there are many more challenges to see. And the next thing is a benefits and the impact. And there are so many benefits. And actually here I have mentioned only 4 benefits and their impacts, which are human-like text generation, efficient information retrieval, and personalization, and multilingual support. And let's see what is this one by one. So the first thing is human-like text generation. It's a well-trained language model can generate a text that appears remarkably human-like, making them valuable tools for content creation and creating writing. The second thing is efficient information retrieval. So by understanding the context, language models enhance the search engine's ability to provide more relevant and search results. And the third one is personalization. These personalization language models contribute to personalized recommendations and suggestions in various application forms, music, streaming to e-commerce. And the last one is multilingual support. And some languages like multilingual BERT can understand and generate text in multiple languages. So, and there are many advantages in language modeling. So I have mentioned only few advantages in this, like foundation of NLP task, text generation, data augmentation, speech recognition and synthesis, mission translation, named entity recognition, which is NER, and the sentiment analysis, question answering, text classification, text summarization, language understanding, and dialogue systems, multilingual applications, and text cleaning and processing. So let's see this one by one. And the language model often numerous advantages in the field of natural language processing and beyond. And here are some of the advantages, right? So the first thing is foundation for NLP tasks. So the language modeling forms the foundation for many NLP tasks. So by understanding the statistical properties of the language, models can generate coherent and contextually relevant text, aiding tasks like text generation, summarization, and translation. And the next is text generation. So in the text generation, the language model excel and generating like that is contextually appropriate and coherent. So this is valuable for applications like chat box, content creation, and personalized recommendations. And the data argument. Language models can be used to augment training data by generating additional examples with various wording, structures, and styling. This can improve the robustness and generalization models, especially in case of limited training data. And the next is speech recognition and synthesis. So the language models contribute to speech recognition by improving the accuracy of converting spoken languages into text. Similarly, they also they also add this in many. And the next one is mission translation. The language models are essential for mission translation systems. They help in understanding the structure of sources and target languages and generating the translations that preserve context and meaning. And next is NER, which is named entity recognition. The language models can assist in NER tasks by identifying and classifying named entities, such as names of people, organizations, and locations, and more, which is important for information extraction. And the sentimental analysis. In this sentimental analysis, the language model aid in sentiment analysis by understanding the sentiment expressed in the text, whether it's positive, negative, or neutral. This valuable of gathering public opinion and customer sentiment. And next thing is question answering. And the language models are used in question answering systems to compress the questions and generate accurate and relevant answers from large amount of text data. And in text classification, language models contribute to text classification tasks such as categorization, news articles, emails, and social media posts in different classes based on their content. And coming to the text summarization, language models can be employed to generate concise summaries of longer pieces of text, which is useful for condensing information and aiding the information retrieval. And the next one is a dialogue system. In dialogue system, the language models are integral to building a new natural and engaging dialogue systems or chatbots that can understand user inputs and generate contextually appropriate responses. And in multilingual applications, language models that support multiple languages. So facilitate cross-lingual tasks, enabling transition, sentiment analysis, and other NLP tasks across the different languages. And the last one is text cleaning and pre-processing. The language models can assist in text pre-processing by handling tasks like tokenization, steaming, and limiterization, which are essential for preparing text data for analysis. And we also seen what is tokenization. And overall, this language modeling provides the fundamental understanding of how languages work and enabling NLP application to process and understand and generate human languages in diverse and meaningful ways. And now we are going to talk about the text summarization. So in this text summarization, we are going to do something new for this. And our team members are myself, Shweta, and Aisha Devi, and Fatima Nubinisha. So have you know what is text summarization? So this helps us a lot. So generally, if you are not knowing about the if suppose you just imagine that you are having a big paragraph and you don't want to read it completely, and at that time you just feel like if someone tell what summary, it will be better easy to us to grab the content, right? So let's see what is text summarization. So um, in this text summarization is a process of condensing a longer piece of text, such as an article, document, or other forms of written context into a shorter version while retraining into a main ideas, key points, and important information. And the goal of this summarization to capture the essence of the original text is a concise and coherent manner, making it easier and making it simple. So, with an ever-growing length-ready textual context present at the internet, computerization trees era stays a critical problem for honest language information. This project discusses the main thing in this is challenges of automated text summarization and the proposes two approaches to tackle it. The first approach involves as a pipeline and that generates a summary meaning representation, which is AMR graphs, and extract a summary graph and generate summary sentences. The second approach uses a report text encoder based on BERT for both extractive and abstractive summarization. And the extractive model stacks inner sentence transformer layers on top of the schedule to elevate the mismatch between the encoder and decoder. And also, the experiments on 3 datasets shows that both approaches achieve the state of that art results. And also, this text summarization is one of the important tasks in natural language processing. And we also know that there are two main approaches in this text summarization. One is extractive and another one is abstractive. We just see what is, let me tell you what is extractive and abstractive. Extractive summarization is like in this approach, the summary is created by selecting and extracting the sentences or phrases directly from the original text. And the selective summarization typically involves ranking sentences based on their evaluations and important, and then choosing the top ranked sentences for the summary. So while this method can provide a summaries that are coherent and maintain the original wording, it can sometimes result in summaries that lack fluency and natural flow. And the second one is abstractive. In this abstractive summarization, it involves generating a summary that may include new sentences not present in the original text. And this approaches requires the model to understand the context, and creativity refaces it to from a coherent and concise summary. And this abstractive summarization often involves in natural language generation techniques, which can result in summaries that read more fluently and human-like. And however, generating accurate and coherent abstractive summaries is more challenging task. And this text summarization has also numerical practical applications, including like information retrieval, as we have seen, and context aggregation, documentation management, search engine snippets, and documentation skimming, right? And also there are few challenges in text summarization. Like we can also say the information compression is also one of the challenge in text summarization, and context selection and context generation, ambiguity and context, handling different types of the text, and preserving those core concepts is also the, I mean, like these are the few challenges which we face in this text summarization. And and also we can have some approaches and techniques like supervised learning, unsupervised learning, and deep learning, attention mechanisms, and reinforcement learning. So in likewise, we are selected those two methods in this project, so which we are going to do in this. And when one is AMR and the second one is BERT. And also there are a few real-time applications like news summarization, context curation, research paper abstract, and legal documentation summaries, and chatbots and virtual assist. So like these are a few things which is very, very important, right? In these applications also we use these kinds of algorithms, from deep learning and ML. So, and condensing a substantial amount of information is a concise summary, while maintaining the key points and the context can be challenging. So, these challengings are a very like a stone thing, like which we are going to go from that. And the in like content selection is also one of the challenges which I have said before. And in this, for extractive summarization, deciding which sentences to include in the summary requires identifying the most relevant and the important information. And the next challenge is like the context generation. In the abstractive summarization, generating the coherent and grammatically correct sentences that captures the essence of the original text while introducing the new phrasing can be a difficult, right? And the next one is ambiguity and context. Understanding the context and resolving ambiguities in the original text is a crucial for creating accurate and the meaningful summaries. And the next one is like we can also say the handling different text types. Like we can see that so many kinds of text in a different way, right? And like summary summarization techniques need to be adaptable to different types of content, such as news articles, scientific papers, legal documentations, and more. And preserving the core concept is also one of the challenges, right? And ensuring that the core concepts and the main ideas of the original text are not most during the summarization process. So, and the last, those real world applications which may also help in the NLP. And also we can see some more challenges in this text summarization. So based because of this text summarization only, we can easily understand the concept and we can grab it easily, right? uh, so that's all for this. I hope you have understood the concepts, and thanks for listening. Thank you.